In this video I'm going to show a Python script for rigging and skinning in Blender, and I think that there are add-ons that might do a better or faster job, but I'm going to go over the code and explain the commands that might make something like this work. So first I want to look at a workflow that a studio might follow for character creation. Looks like this. But there's another way to think about project workflow in general, and that looks like this. Sometimes if you start a project off with aesthetics first and add functionality later, you might run into problems caused by the way the mesh was originally modeled. So when you get to like this animation stage, you might figure out that your model needs to be changed and you might have to somewhat start the process over. So if it's possible to get functionality out of the way first, it frees you to experiment and learn as you go. And you might not think that animation requires scripting, but it can be easier to make changes or correct mistakes. Another way to think about the difference between a linear or destructive workflow and a non-destructive workflow is this. On the left is like a stack where if you pull out any one of these boxes, the whole project sort of collapses. But if you organize your project modularly, or think about it kind of like a network, it can be easier to change one particular element without affecting the whole project. And one of the first games I made was organized more like this. It was sort of a giant mess of a blend file. But when I finished, I kind of took it apart and reorganized it and made it look more like this. And that could make working on the next project a lot easier. So I'm going to show a game character that I created and spent a lot of time on. And despite that, I want to recommend that instead of using a finished model on a project, you use a sort of like low quality stand-in for characters as well as like any props or background objects. Complete the project first, and then you can go back and polish it up if you still decide you want to. But if you think you like it as it is and would rather work on a new project, then you can. And that might mean you have to rig your characters twice, but if you use scripts or add-ons, that might not be such a big deal. So here's a character I created, and I'll say a few things about this. The first is that the geometry is not the best. It does have some things that are good about it. Like for example, there are loops around the mouth and the eyes. If you wanted to animate those, then loops are more conducive to that. And the loops in the shoulder somewhat extend up into the body, which is what you want so that you can get a clean bend. Same with the hips. You want the loops from the hips to continue into the body. And I think what you want your mesh to have is basically all quads, as opposed to like these triangles up here. This is kind of messy. This group of 5 quads is where a grid of quads is created by the kind of grid-like shape of the jaw joins with the loop of the mouth. And there's another one right here where this grid that's coming from the jaw joins with the loop of the eyes. So this mesh was a lot more difficult than I thought it was going to be, and one reason for that is the closer that I got to how I wanted it to look, the easier it was to mess up. So there are a few times where after working for a few hours I decided that it looked worse than when I started. It works a little bit like a house of cards where the higher you build it, the more fragile it becomes. So if you're working on a complicated model, be sure to back it up frequently and make small changes at a time. Look at the model from different angles and decide if it's better than your backup. Otherwise you might end up going in circles. And that could be another good reason to use stand-ins. Um, if you find that after a lot of hours of work you run into problems in the functionality stage, you might not enjoy working on the project. You could become easily frustrated. So if you're making a game or animation and you need a character, you could try just using a sphere for the head and maybe some sphere for the eyes, and just make sort of some very simple hair. And you might try adding one distinguishing characteristic like a hat or some glasses. And then the bodies can all pretty much be the same, except for maybe the color of the clothes. And when you've done that once, you have pretty much as many characters as you would ever want. You can also make scripts to randomize the color of the clothes, hair, and skin, or maybe scripts to swap out different hairstyles. And any game that can be made with simple characters is essentially the same as any game with more detailed characters in terms of gameplay and content. And higher polygon counts will slow down renderers and game engines. And animation is probably a little more dependent on a certain aesthetic in terms of how it communicates a certain idea. But it's those ideas themselves that I think should be the focus of the project. So here's a script that has these rigging and skinning functions. I'm going to delete all this and copy this example usage code. And then I'll just implement one block at a time. So my character's name is Bean. And the minimum number of spine bones is 3. There's a spine bone at the bottom of the pelvis, another one at the middle of the pelvis, and a third one where the left and the right clavicle joins, and that forms a new branch that joins with the shoulder. I'm going to add one more spine bone. I'm going to place it here in the middle, and that will allow the spine to bend a little bit more. The shoulder count, I'll add an extra bone to add a little bit of bending in the shoulders. If you set the minimum to 1, there's a shoulder bone here. Here's an elbow bone there and a wrist bone there. But I'll add one extra shoulder bone and place it about there. I'll add 2 extra hip bones because where the hips form into the waist, you can get a lot of problems with the mesh kind of becoming creased, and adding extra hip bones can help to alleviate that. So the first function I'll call is this rig read, and that puts this first configuration that I'm going to use into a list. And for each entry in this list, there's the first element that denotes the position of the head of the bone. The second entry specifies the tail of the bone. The third is the name of the bone, and the fourth is the location of the bone. And I made another configuration, and this one's basically the same except it has fingers. For this one will return 5 branches. Each double quotes is the start of a new branch. So for this, you need to make room for more branches to be returned. There's also an option to load an armature configuration from a file. This list kind of just organizes this rig list and implements these extra bone counts. and it pulls out those locations and puts it into a separate list. This rig list is basically just a big concatenation of all of these 5 branch lists. And I'll explain a switch and a region list later. So the 5 branches, the first one is the spine bone. It starts down, or the spine branch, it starts at the bottom and moves to the top of the head. And that's opposed to moving from the top to the bottom, and that's because bones rotate from the head. So if you're to rotate, like say a pelvis bone, that goes from the top to the bottom, it would cause the legs to float. The second branch branches from this top spine bone and moves down the arm. The third branch is the left leg, the fourth branch is the right arm, and the fifth branch is the right leg. So I'm going to call this marker create function to create some empties that represent the position of my bones. And this manipulating these empties, it's not that much different than manipulating the joints in an armature, but I think it's a little bit easier. So I'm going to place this first spine bone at the base of the pelvis, the second spine bone at the top of the pelvis, this extra spine bone I'm going to put in the middle, and the top goes sort of in between the shoulders. The neck goes at the base of the neck, the head at the base of the head, and the top goes at the top of the head. There's also an align function to align the X and Y positions for the first branch. I'm going to skip that, but I'll show how the align function works for the second branch, which is the left arm. So first I'm going to set the height of all the markers in this second branch. The hand goes at the tip of the hand, the wrist goes at the wrist, the elbow, and the shoulder. And this extra shoulder bone I'm going to put just underneath the first one. Then I'm going to set the XY position of the first shoulder bone. And I'm going to call this align function, and I've set the align index to 1 as opposed to 0, and that specifies that for the bones to align to the second bone in the branch. The first bone is the spine bone, so I don't want to align to that. So setting the align index to 1, it will skip that bone and align to this bone. So when I run that, basically it didn't exactly work. I forgot to comment out my marker create function, so I'm going to undo that. Try it again. Okay, that's what I wanted to do. Then I'll set the Y position of the hand, put it under the wrist, set the Y position of the wrist. Actually, I think I'll move that back a little bit. Well, I'll just do this. And I'll set the Y position, the elbow marker, move that back a little bit too. And then this one, move down a little bit also. So then for the third branch, I'll first set the height, ankle, knee, and I'll set the top hip bone about there somewhere. And the second extra hip bone I'll put just below that. And for the third hip bone, I'll put a little bit more of a spacing between each subsequent bone. Then I'll set the XY position, move it in and back a little bit. And then again I'm going to align to the second bone in the branch because the first bone is the spine. So when I do that, that puts all these markers. That didn't work. I didn't save it. So I'm going to undo that. Try it again. Okay, so there. And change the X of the foot bone. Move the ankle. The knee. And that should be fine, hopefully. So now that I've set the left side, I'm going to make markers for the right arm and right leg. Now I can create my armature, and this basically works one branch at a time. So there's my armature, and the way this armature is connected was set by the rig read and the rig list functions. So the next thing I'm going to do is set the bone roll to 0 and set the pose rotation mode for the bones. So when I add an armature, for some reason I get this bone roll, like this is -15, this is -75. I'm not sure why it does that. And for the rotation mode, I want it to be in Euler instead of Quaternion. So I'm going to run my script again, and that set my bone roll to 0. And now the rotation mode is all in XYZ Euler. So these bones that are highlighted have a constraint that's been added to them. So for bones like the elbow, I rotate them normally, but for bones like these, like the hip, I have a sort of master rotation object that's going to rotate all three of these at once. So I'm going to hide this mesh for a second. So when I rotate this, it kind of causes this bending, which can sort of smooth out problems in the mesh. And that works through this bone constraint. The target is the rotation object, and this influence determines what percentage of rotation from 0 to cause the bone to rotate. And what I did is I just divided the influence by the number of bones, which is kind of arbitrary, but you can go in and set this manually if you want it to rotate a little differently. So the next thing I want to do is there's this option when you parent a mesh, or actually first I want to apply the mirror and parent the mesh to the armature. So here I have this mirror modifier that is copying the left side of the mesh to the right. I'm going to go ahead and apply that so that my the left side or the right side of the armature can change the mesh independently. To parent the armature of the bone, or the mesh to the armature, I'll select the mesh, and then hold shift and select the armature. I don't know if this needs to be in object mode, but just in case. Then I'll hit Control P, and automatic weights I think will give a good starting point for weight painting. So I'm going to select that, and then I'm going to parent the armature to this main character empty. So now everything is all under a single parent. So when I parented the mesh to the armature, Blender automatically added this armature modifier, which deforms the mesh based on the rotation of the bones. And I like to select this preserve volume option. I think it looks a little bit better. So that's what this function does. It basically just sets that one option. The next thing I'd want to do is I have these sort of accessory objects, like the necklace, or all these hair pieces are individual meshes. And so rather than do all that manually, like there are a lot of hair objects, all of these strands are a different object. So I definitely don't want to do that manually. I have this extraneous scripts, and if I run that, I put all of these extra objects into a list, and you can use a script to do that. And then this function will add the objects in this list to this bone, to a vertex group with the same name, so that the armature deforms those objects as well. So after you've applied your armature to your mesh, what you want to do is pose the mesh, and what I do is kind of weight paint out the problems like this. This vertex group comes up a little bit too high, so if you select the mesh and go to weight paint mode, then select the group, the vertex group that you want to weight paint. You can basically just subtract out this weight until the waist goes back underneath the belt. So something like this. So you basically want to do that for any position that you want your mesh to be in. You want to kind of try to paint out those problems, pick a different pose, paint out the problems again. And I'm not going to go through that whole process because it's kind of time consuming. It could be a little bit tedious. And I'm actually not a huge fan of the whole rigging and skinning process in general. I find it to be a little bit finicky. So what I'm going to do now is show a workaround. It doesn't produce as good of results, but it's a much more straightforward process. So I'm going to reset these rotations. delete these rotation objects. Unparent my mesh. And then delete my armature. So what I'm going to do now is split the mesh into different parts that can be rotated independently. And I'm going to reuse these rig objects, but I don't need all of them, so I'll delete some of them. I'm going to keep the head marker to mark the position where I want to separate the rotation of the body from the head. I don't need this one, and I don't need any of these extra markers, so I'll delete those, and I'll remove the instancing on these first bones. And the way this next script works is it uses these markers to find a close by vertex. So let's say the nearest vertex to the location of this marker was like here, then it's going to try to find a loop that vertex belongs to. And since this vertex is surrounded by 4 quads, there are 2 possibilities that the loop direction can be in. One is this one, which I want. Another is this one, which I don't want. And up here you can see there are 95 vertices in this loop. In this one there are fewer, and that's how the script is going to pick the loop. It's just going to pick the one that has the fewer vertices in it. So let's say I wanted to pick this loop. I'm going to move this marker to that position, and then I'll reflect it to get the other side. So in order to test if my loops are being selected the way that I want them to, first I'm going to get a list, split list. This is a list of all of these markers. To test the first loop, set index to 0. I'm going to retrieve the name of the marker from rig list. This basically just figures out what this number is. And the number is basically just to sort the bones. So I'll run loop near for the head. I'm going to save my script. So that looks like what I want. It's a loop that goes around the neck. Test the wrist. So it selected the wrong loop. It's going up and down the arm instead of around it. So to fix that, I'm going to set this switch list, and I want the second bone in the list, and I'm going to set switch to true, and then try it again. So that's what I want. So then I'll move on to the elbow. Shoulder, and ankle, since I inverted the wrist, I want to copy that to the right side. So the right side, there's 3 arm bones. So this is 7. I'm going to test it. So now that all the loops are selected the way that I want them to, I'm going to back up the location of the loops to a file. And the reason I want to do that is because when this mesh starts to become separated into different pieces, it can change the way this loop near function works. So I'm going to back them up first and then read them from the list. So that can take about a minute to finish. So while that's going, I'll explain another feature in this rig list function it's facing. So a lot of people, when they have models in Blender, they face it towards a negative Y. I like to face mine towards positive X, because if you want your character to face say like a certain object that's located in the XY plane, then you can take the arctan of XY and that will give you the Z angle that your character should face. And that's what I have here. So something like this is the facing angle, and this is the XY position of the object that you want your character to look at. So that's it's pretty simple and straightforward. If your character is facing negative Y, then you have to adjust this. And it might not seem like such a big deal, but when you have like multiple parents and you have to sort out the difference between the world location and local location, it can start to get pretty confusing if you're trying to script out like animations like walk cycles and run cycles, and you're trying to calculate the position of a bone without the facing angle affecting that. But if your character is facing negative Y, then you can just set this to -Y, and that will rotate the locations in all of these location entries. So here's this list that my loop list function made. Here are the 13 bones, and there's 2 locations for 2 vertices that are in a loop. So I can use those locations to find those specific vertices again without having to run the loop near function. So now to load that list, I'll use loop list read. And I'm going to pass that to the mesh split function, which will split my mesh into different pieces. So I'll run that, and this can take this will take maybe five or so minutes to finish. So I'll start to describe some of these functions. So bone name split separates a bone name into its different elements. Like here I have a specific naming scheme for all of these bones. I have the character name followed by the rig prefix, followed by the index, followed by the bone name, followed by the bone side. Okay, that's done. And then if I have multiple bones, it's followed by a bone instance. So this this separates all that and puts it into a list. Concatenate and concatenate list. Put the names back together. So if you pass like a part of the bone name, then it can add these prefixes in. Okay, so my mesh is split into different pieces, and also these script have added like a kind of cap to the top of each bone, and kind of a socket to the bottom of each bone, so that the bone can rotate in place a little bit better. Next thing I want to do is set the parenting, and I've already put the way the parenting is organized in this parent dictionary. I'll show that. Diff split definition, the split root function. So here are the names of all the bones. The parent dictionary gives what I want the bone to be parented to. So I want to parent the wrist to the elbow to the shoulder, and the shoulder to the body. The flip list is whether I want to flip the normals of these ball joints, and this also the socket joints. So I'm going to run these lines to parent my bones. And I'll parent my body to the character again, so that everything's together. So now these bones have kind of a hierarchy. The knee is parented to the hip, ankle to the knee. So now instead of rotating an armature, I rotate a mesh. Also, obviously I want the sandal to follow the ankle, so I'll do that next. First of all, my sandals are mirrored, so I'm going to apply the mirror, duplicate them, make a sandal left and a sandal right. And delete the side that I'm not using. So in this extraneous script, I have the functions that it's basically the corresponding code for an armature. Is it's a parenting instead of adding armature modifiers. So copy and paste that, and run it. Now the sandal follows the ankle. Also, all this hair has been parented to the head, so you can rotate the head. Well, the eyes need to be duplicated as well. And then so that's more or less all that I wanted to show for these. It's kind of the main idea is that these two different ways of rigging a character. I've also made some different functions that are just kind of miscellaneous. There's a loop region function that can select a region between two loops. So like, let's see what happens if I run this. I don't know if this is going to work, because you're supposed to use this with this other armature configuration here. Yeah, it's not going to work because the mesh is split up. But this will select a region between two loops or between a series of loops. The skin all function will create vertex groups based on these regions. So this is the same idea where I tested the loops and then I used the loops to split the mesh. You can test the regions and then use the regions to create different vertex groups, and then to add armature modifier to those objects so that those vertex groups apply to a certain bone of the armature. And there are a few more functions for like this one, back up and restore the position of vertices. So these kind of these ball and socket joints, they don't always fit perfectly. Like if I move this out, there's a gap. So you could kind of fix that by, there are different ways, but one way to kind of help with that problem is to move this down a little bit, and then when it rotates up, they just kind of intersect and it gets kind of hidden. But if you're editing certain parts of a mesh like this ball joint, and you want to preserve the rest of the leg, you can do that. Like if I back up, if I run this script, that will back up the position of the vertices, and then if I change them, I can run the script to restore them. And the weight backup and the weight restore is the same idea. So I'll show that. So if I have a certain weight paint that I want to preserve, I can run the weight back script, and then if I change it, I can restore it. So if I restore, I return to those weight paints, and those are stored and loaded from these files. Actually, they should be in this list folder, so I need to update that. And that can help with kind of this issue that I mentioned where you get to this spot and you realize, or maybe you even get to here and you realize you need to change this. You can sometimes restore your weight paint. The problem is if you add vertices to your mesh, then your vertex groups might change. So you might be restoring a vertex group that doesn't look the same. So it's not ideal. That's another reason I like to split the mesh into different pieces. So that is sort of the usage section. Now I'm going to just go through this whole script and show all the different functions that made the script work. So I already showed these. You saw the rig read function. The rig list kind of sorts these entries and implements these different counts and the facing direction. So here's where it checks to see if there's extra bones, and if there are, then it adds these bones in between. Just kind of splits the difference between the beginning bone and the end bone. And the rest is just kind of boring naming stuff. Apply my facing by reflecting the markers basically. Here's what mark create looks like. You saw what that does. It's fairly simple. Align just copies the XY location to the other entries in this list, and it starts here. Mark reflect copies the markers from one side to the other. Mark reflect location is used by this function, and it reflects the X or the Y location, depending on which is bigger. Mark reflect name just gets the opposite side. So if you pass like this marker, then it will fetch this other marker. Rig is the function that creates the armature and positions the head and the tail of the bones. Here's where these constraints get applied to the bone. It's copy rotation constraints. That's if the length, or if these counts are higher than the default. Here's where I place the head of the bone. Alright, this is the head. I think this is the head of the first bone. This is where an armature gets created if one doesn't already exist. And then this is where I place the subsequent bones. Extrude a bone, place the head, place the tail, name the bone. Master rotators. This is more master rotation options. And this is the master rotation function. This is at the top. That's here. Starts there and ends there. Bone roll reset just sets the bone roll to 0. Bone rotation mode sets to XYZ. This sets this preserve volume option for the armature modifier. Mark read. This you can use to get the full name of a marker. So I can pass like shoulder.r and I can get this index, and it retrieves that from the rig list. Loop mirror is the function that selects a loop based on the vertex that's nearest to the marker, and there are different options. One thing you can do with this loop near function is, let's say for some reason I wanted the elbow bone to be here, but then I wanted to select a loop that's down here. Then I could name this object to loop, and it will place the head of the bone here, but it will use this loop for vertex skinning. I can also make multiple loop markers to do a path selection. So I could do something like this, duplicate a bone. If I wanted to form like a path that uses the shortest path function, that is somewhere here. Loop region selects a region between two loops or between multiple loops. It also has a fill option to select from a loop to the end of the object. So like if I wanted to select from this loop all the way down to the end, well, it actually depends on which end is closer. So it's going to call this command, this loop inner region, and that automatically just goes to the closer end. So that's what passing an F will do. Skin creates a vertex group based on a region. Skin all does that for a list. Skin extraneous is for skinning like an accessory object, like a necklace or a strand of hair. Split read, this is the list that I use to split the mesh into different pieces. These are all the different pieces in the final result. Parent list, I showed this. This is the parent of each bone. Loop list. This one returns a list of two vertices that make a loop. It returns their location. Loop list to read reads the loop list file. This should be loop list to writes first to the loop list file, and then reads it. This is the mesh split for each bone in the split list. It first calls mesh split, which splits the mesh into two pieces, and then it makes the socket, and then it makes the ball of the joint. Mesh split part splits the mesh. It also purges materials that aren't being used anymore. Ball and socket creates the cap of the different bones. This purges unused materials. This checks to see if the material count is 0, and if it is, it removes it. Backs up the vertex position, restores them, backs up the weight, and restores the weight. That's pretty much it. So that's the end of the video. I hope you enjoyed it. Thanks for watching, and see you in the next one.